So finally, we come to the last chapter of NCRT, that is probability. Very easy chapter. And there are a few things that we should know. First of all, what is the definition of probability? Probability is number of favorable outcomes by total outcomes. Okay. So what is probability? This is the formula PE. E stands for the event. Probability of an event is number of favorable outcomes. Okay. What is favorable to you upon the denominator is all possible outcomes, right? So this is the formula by which we will have to solve all the questions. The basics of probability you have already done in class 9. You know that the sum of probabilities of all elementary events of an experiment is always 1. An impossible event probability is 0 and probability of a sure event is 1. And therefore answers will always lie between 0 and 1. You cannot have a negative number. You cannot have a number greater than 1. All your answers will be between 0 and 1, right? So probability is defined as, if I ask for the definition, it will be you are calculating the chance of occurrence of an event, right? So probability is defined as the chance of occurrence of an event, and when the event has to occur, we denote it by PE, right? And just to make sure that you've understood that anything which you're sure of, that will always be 1. What is the probability that the sun will rise from the east? You are 100% sure. When you are 100% sure, the answer is 1, right? 100 upon 100, that is 1. So probability of sure event. And what is impossible? What is impossible? Probability of an impossible event is always taken as 0. Okay, so probability of sun rising from the south, right? That is 0. So probability of sun rising from north is 0. Or today is Sunday. What is the probability that tomorrow is Wednesday? Impossible. So anything which is impossible, that is 0. So all your answers, remember, has to be between 0 and 1. Probability of an event will always be greater than 0, but less than or equal to 1. Okay, so this is the basics. Okay, now once we know the basics, we can go through the questions. The first question, probability of an event happening and the probability of the event not happening. Okay, so here PE, this is the probability that the event happens, and PE dash, or in some books they will give you PE like this, a line on top. Both this means that the probability event will not occur. Okay, so PE, probability that the event happens, and the probability that the event will not happen, E dash, is always equal to 1. What does it mean? Suppose they are asking you, what is the probability that is raining? Okay, let's say probability of raining is 0.6. So what is the probability that it will not rain? It will not rain. So that will be 1 minus 0.6.4. Okay. What is the probability of losing if probability of win is 0.8? The probability that you are going to win the game is 0.8. So probability that you're going to lose the game will be 1 minus 0.8.2. So always remember this total has to be 1. So PE plus PE dash is always equal to 1. So probability of an event happening and the probability of the event not happening will always be equal to 1. You can denote this. Probability of an event that cannot happen is, when you cannot happen, it is always 0, and such an event is called an impossible event. Okay, 0, impossible event. The probability of an event that is certain to happen, if you're 100% sure it will happen, the answer is 1, and such an event is called a sure event. The sum of probabilities, as I explained, will always be equal to 1. Whatever is the sum, the total probability always has to be 1. Probability of an event is always greater than or equal to 0 and less than or equal to 1. So it has to be 0, greater than 0, but less than 1. Of course, 0 and 1 is included. Okay, next we come to an important question. Which of the following experiments are equally likely? So let me explain the meaning of an equally likely event. What is an equally likely event? An equally likely event is an event which have exactly equal outcomes of, for example, you're tossing a coin where the chance of occurrence of each outcome is exactly the same. Okay, the chance of occurrence, the chance of occurrence, of all the outcomes, of all outcomes are exactly same or identical. Okay, there are very few events like that where all the events will have exactly equal chance of occurrence. Okay, so chance of occurrence of all outcomes are exactly same. The best example is tossing a coin. When you toss a coin, you're going to get either heads or tails. What is the probability that you will get heads? Probability of getting heads is equal to 1 out of 2 because there are two outcomes. Okay, when you toss a coin, that is the event, and these are called the outcomes. So outcomes are heads or tails. So probability of getting a head is 1 by 2, probability of getting a tail is also 1 by 2. Such kind of events are called equally likely events, or for that matter a dice. If you take a dice, roll a dice, you can get 1, 2, 3, 4, 5 or 6. All the numbers have equal chance of occurrence. Not that every time 3 will come or 4 will come. Then that is called a biased die. We are talking about an unbiased die. Okay, unbiased die. Okay, so in an unbiased die, okay, when we throw or roll a dice, the probability of each number, what is the probability that 1 will come? It is 1 out of 6. What is the probability that 2 will come? That is also 1 by 6. Probability of 3 is 1 by 6. So every number has got equal chance of occurrence. So these kind of events are called equally likely events. Okay, but if suppose I ask you, is it going to rain or not rain? Okay, are the outcomes exactly same? Most people have the confusion in this. Some will say, yeah, that is a 50% rain or chance always. No, this is not an equally likely rain. Raining and not raining is not an equally likely event. It depends on the humidity present in the atmosphere. If the humidity is high or it's rainy season, the probability of rain will be very high, maybe 90%, maybe 80%, and maybe 10% and 20% in this case. So it's not equal. It's never 50-50. Either the problem, if it is dry months, the probability of not raining will be high, and the probability that it will rain will be low. So depending on region, every day and every location will have different probability. But in case of coin or dice, it doesn't depend on the location and time and actually whether you are doing in the night or day, the probability is going to be same, right? But not for a rain or sun. So if you say what is the probability of getting a head, it is always 1 by 2 irrespective of location and time, but not in the case of raining. Okay, so I hope somewhat it is clear. Let's take more example. You are trying to throw a basketball in the basket. You are trying to throw this ball. What is the probability that he is going to get it? Is it equally likely or no? That is the question now. Is it an equally likely event, throwing of a ball in a basket? Okay, again you will say, okay, there is a 50%, it may go or may not go, right? You think that some of you are thinking that way, that this ball may go or may not go. So it is an equally likely event. Answer is no. It is not an equally likely event. Why? Because if the person is a professional basketball player, the probability of going will be much higher. Okay, and the probability for a common man who is not playing basketball, the probability for his ball going will be low. So in tossing a coin, it doesn't depend on the professional expertise. It depends on only the event. Here, who is throwing the ball, it depends on that. So probability will be very high for professional basketball, NBA team basketball players and all. They will have a high success rate, 90%, 80%, 100%, right? You have heard about Magic Johnson and Shaquille O'Neal and all those big bosses of NBA. So all those will have very high percentage. Whereas for others, it will be very low. So throwing of a ball in a basket is not an equally likely event because for different people, it will be different. You are having a vehicle, starting of a vehicle. Okay. Is it an equally likely event? Okay. Is it an equally likely event? Starting of a vehicle, is it an equally likely event? Okay. Many of you say it may start or may not start. The chances are 50-50. I know that many of you are agreeing with this. It may start or may not start, 50-50 chance. Again, false. Okay, because when you are having a vehicle, what is the probability that it will start? Okay, you have a vehicle, car or something. Out of 365 days, if you let's say take it 364 for convenience, if you are saying that it may start or may not start, that means 182 days it did not start, and 182 days it started. So is it true or false? False, because When you are having a vehicle at home, the majority of the times it will start. Majority of the times for the majority of the people. Of course, if you are having a very old vehicle, it may not start. Then it will not start at all. It is again, it's not going to be 50-50. Because if the probability of starting a vehicle is 50%, then it's a very risky situation. Okay, you are going to school, then you are every time you are having that doubt, will my vehicle start or not? Okay, but every time I get into my vehicle, I am confident that it will start, I will reach my destination, right? So you have to see what is happening in the majority of the cases. Okay, if one or two vehicles may be in bad condition, but millions of vehicles will start. So you can neglect those one or two. You can say it depends on the condition of the car. So what are we seeing? We are seeing the majority. Majority is not 50%. Okay, either it is going to start the majority of the times. Okay, in 10 years probably you will experience a problem once or twice in your vehicle that it is not starting. Okay, and if it is it's a brand new vehicle, there is no question of getting any problem. So you see millions of vehicles around you, lakhs and lakhs of vehicles. Every time you find that the person is sitting in the car and it starts. Very rare cases it doesn't start. So it is not an equally likely event. So these are the questions here. Driver attempts to start a car, the car starts or does not start. I have explained it is not an equally likely event. It is not an equally likely event because in the majority of cases, it will start. A player attempts to shoot a basketball. This is not, again, I explained to you, it is not an equally likely event because it will depend on the person who is shooting the ball. That is, if he is a professional, his chances will be very high. For a common man, it will be less. A trial is made in a true and false question. The answer may be right or wrong. Okay, so if you, this is an equally likely event. So if it is a true and false question, the chances are exactly 50-50. A baby is born, boy or girl, again 50-50. You have equal chances that 50% chance you've done in biology, XX and XY chromosomes. So the chances are exactly equal for boys and girls. Okay, so I hope you are clear with this. This could come in a 1-mark question or a 2-mark question. Why is tossing a coin? Next question, we are going to question number. Why is tossing a coin considered a fair way of deciding which team should get the ball at the beginning of a football game? Right? So tossing of a coin, I told you, is an equally likely event. So whoever is going to choose whichever, we are not giving advantage to anyone. Okay, nobody can say, oh, he chose head and I chose tail. You know, heads always comes or tail always comes. So the probability of head, as you observe, is always 1/2, and probability of tail is also 1/2. So this is going to be an equally likely event. So I will not complain. If a decision has to be made, then if I toss a coin and decide, nobody is getting an advantage. So I will say tossing a coin is an equally likely event. Therefore, probability of head and tails are exactly equal to 1/2. Question number 4. Which of the following cannot be probability? We discussed that probability cannot be less than 0 and cannot be more than 1. So 2/3 is 0.66 possible, minus 1.5 not possible. It cannot be negative. 15% is 15 upon 100, 0.15 possible, 0.7 possible. So everything is between 0 and 1 except for this, which is less than 0. So this cannot be negative, and therefore this is the answer. PE is 0.05. What is the probability of the event not happening? Probability of the event happening is 0.705. What is the probability that it will not happen? So the total probability is 1. So 1 minus 0.05, you get 0.95. These are all easy questions. A bag contains lemon flavored candies. Malini takes one candy without looking into the bag. What is the probability that she takes orange? Now see, the bag has only lemon, so orange cannot come. It's an impossible event. So probability of orange will be 0, and surely you are going to get lemon flavor, so that probability is 1. So answers are 0 and 1 because it's a sure event. This is impossible event. Okay, the probability that two students do not have the same birthday is 0.992. What is the probability that two students have the same birthday? So what is the probability that I told that probability has to be 1. So the probability that the same birthday does not occur is 0.992. So the probability that same birthday occurs is 1 minus 0.992, that is 0.008. Next question, question number 8. A bag contains 3 red and 5 black balls. A ball is drawn at random. What is the probability that it is red? So how many balls are there? 3 plus 5, 8. out of which 3 are red. So probability of red will be favorable is 3, total is 8. Probability will be 3 by 8. And what is the probability that it is not red? Not red will be, obviously they are referring to black. So that is going to be 5 by 8. Then question number 9. A box contains 5 red marbles, 8 white marbles, and 4 green marbles. 1 is ticked. What is the probability that it will be red? So look at the number of marbles here. 5 plus 8, 13. 13 plus 4 is 17. You have 17 marbles in total, right? Out of which red is asked. So probability of getting red will be 5 upon 17. Probability of white will be 8 upon 17. And not green. Not green means it can be red or white. So 5 plus 8, 13. 13 upon 17. Direct questions, 1 or 2 more questions. Question number 10. A piggy bank contains 100 50 paise coins, 50 1 rupee coins, and 20 2 rupee coins, and 10 5 rupee coins. Okay, it's an equally likely that any coin can come. So what is the probability that it will be a 50 paise coin? So how many coins are there? First of all, let's see. Here you are having 150 paise coins. Here you are having 50 1 rupee coins, 20 2 rupee coin, and 10 5 rupee coin. So 100 plus 50, 150, 170, 180. Total number of coins that you are having in the piggy bank is 180. Out of which now the question is, it will be a 50 paise. Now, how many 50 paise coins are there? We have 150 paise coins. So what is favorable outcome for you that the 50 paise coin comes? So how many 50 paise coins are there? There are 100. So probability of getting a 50 paise coin will be 100 out of the total we had counted 180. So 100 by 180, 0, 0 cancels, we get 5 by 9. Okay, then let's go to the other part. What is the next part? The probability that it will be a 50 paise coin will not be a rupee 5 coin, will not be rupee 5. So 5 rupee, how many 5 rupee coins are there? There are only 10 5 rupee coins. That means out of 180, only 10 are 5 rupee coins. All the other 170 are not 5 rupee coins. So what is our favorable outcome? That it is not 5 rupee. So probability will be 170 upon 180, isn't it? Because there are only 10 coins of rupees 5. So except for these 10 coins, if I take out the 10 coins, I am getting 170 coins, right? 170 is favorable to me, not rupees 5, no? So 170 and total is 180. So what will I get? I'll get 17 upon 18. Okay, so question number 11 now. Gopi buys a fish from a shop. Now, what is the question? Shopkeeper is taking out a fish at random. If there are 5 male fishes and 8 female fishes, what is the probability that it is a male fish? So total number of fish, 5 plus 8, 13. What is favorable to you that a male fish comes out? So probability will be 5 upon 13. A game consists of spinning the wheel. Okay, so this is an arrow will come and it will point. So 1 to 8. This is also equally likely any number can come. So what is the probability that 8 will come? What is the probability that 8 will come? 8 will come. Answer will be 1 out of 8. What is the probability that an odd number comes? Odd numbers are 1, 3, 5, 7. So you have 4 numbers odd. So 4 out of 8, that's 1 by 2. A number greater than 2, which are the numbers greater than 2? 3, 4, 5, 6, 7, 8. So how many numbers are there? 1, 2, 3, 4, 5, 6 numbers. So greater than 2 will be 6 upon 8, that's 3 by 4. And number less than 9, all the numbers are less than 9. So that's a sure event. So answer will be 1. Okay, so you can complete this. 8 is 1 by 8. As I discussed, odd numbers are 1, 3, 5, 7. So 4 out of 8. That's 2 out of 8. 1 by 2. Then greater than 2, you have these numbers 3, 4, 5, 6, 7, 8. So 6 by 8, that's 3 by 4. And all numbers are less than 9. So all 8 numbers, 8 upon 8 is 1. Okay, question number 13. A die is thrown once. What is the probability of getting a prime number? So please remember, what are prime numbers? Prime numbers are numbers which are not divisible by any other number except by 1 and itself. So it has only 2 factors. So when you are talking about a die, you are having 6 outcomes, 1, 2, 3, 4, 5, and 6, right? So which are the prime numbers? 1 is not prime, okay? 1 is neither prime nor complex. opposite. It has only one factor. Prime numbers have two factors, 1 and itself. So 2 is prime because 2 and it goes by 1. 3 is a prime number, 3 and 1. 4 is not prime because it has factors of 2, 2 and 1. 3 factors it has got. 5 is prime. 6 is not prime. So prime numbers are 2, 3 and 5. So 3 out of 6. 3 out of 6 is 1 by 2. So probability of getting a prime number will be 1 upon 2. What is the probability of a number lying between 2 and 6? So when you say between 2 and 6, 2 and 6 are not included. Okay, between 2 and 6 will be 3, 4, 5. So 3 numbers are there. 3 out of 6, that's 1 by 2. And odd numbers are 1, 3 and 5. Out of the 6 numbers, 1, 3 and 5 are odd. So probability of getting an odd number will be 3 by 6. That's also 1 upon 2. Right? So this is up to question number 13 I have discussed. In the next class, I'll be discussing question number 14 onwards.